Hello everyone, welcome back to the channel. Hope all of you are doing good. So this is the fourth video in our last minute interview prep series. First one was SQL, then data modeling and data warehousing, and third one was Spark. And thank you so much for so good response on those videos. Now if you see those three videos, you will see a lot of comments are asking about Python video. So today we are going to do for Python last minute interview prep video. Now, what we will do in this, first, I will explain you, I will tell you that what all topics are important, right? Kind of, I will give you a roadmap that these topics are important, what all you should learn as a data analyst, what are the topics, and as a data engineers, what are the topics. And then I will start solving some questions one by one. I will start with some easy questions, then medium, then difficult. We will talk about how to optimize these questions, how to optimize these solutions, and how to check what is the time complexity, right? So when you go for interviews, you might solve a question, but you might have not got the as per expectation because it might be taking more time than expected, right? So we will discuss how to approach those kind of questions, right? Make sure if you are not very confident about Python, you practice along with me. I will show you some resources also along the way where you can practice Python questions for free, right? So focus on this video, watch end to end, and by the end of the video, you will feel very confident going into the interviews. Okay, so let's get started. So first, let's see what are the important topics and what are the things that you should know before you start solving the questions for interview. Okay, so I have divided Python interviews in two parts. One is coding and one is analytics. So we will see what is there inside each one of them. So if you go to coding, right, there are two things. One is what are the topics you should learn, right? And then what are the patterns, basic patterns that can be asked in your interviews. Okay. So if I go to topics, these are the bare minimum topics that you should learn. And these are the good enough topics to crack any data analyst or data engineer interview. At least 95% of the interviews revolved around these topics, right? So we have variables, if else, loops, strings, list or arrays, dictionary hash maps, right? Sets, tuples, functions, working with file, exception handling, and big O notation, right? So these are the things, if you know, if you are very much clear about these things, then you can easily solve questions asked in data analyst and data engineer interview, right? They are advanced topics, they are advanced data structures. Like for example, you have queues, stacks, you have more advanced topics like dynamic programming, linked list. You can learn that, but I'm telling you 90-95% interviews can be solved, can be cracked using these topics, right? Because see, most of the interviews for data engineers and data analysts are not very hard Python questions, right? They are basic questions or medium questions. They don't ask hard questions. Very specific data engineer roles, right? Maybe some platform engineers or maybe 5 to 10% maximum, right? Those requires those advanced concepts. For you as a data analyst or data engineer, 90% of the time these topics are enough, right? So focus on these topics. If you are very good on all of these and the patterns that we will discuss, then you can learn more things. But if you learn these things, then it will be more than enough, right? So you should learn this. This is Python fundamentals, how to work with list, what is dictionary, what is set, tuples, what is function, how to work with files. So all of these things you should be very comfortable. I will not teach you in this video. This is an interview prep video. So if you don't know all of these things, then you cannot do interview prep, right? So you have to understand these things first, right? If you are a complete beginner in Python, like you don't know all these topics, you are not very good with fundamentals, you don't feel very confident, then you can simply go to namastesql.com, go to courses, and then we have a Python for data engineering course. In this, we have covered all of the important things that you need to know as a data analyst or data engineer for Python, right? We have covered what all topics I just discussed with you. Everything is there. And apart from that also, we have a lot of other things, right? So for example, all the basics are there, working with NumPy, pandas, and we have in-depth pandas video as well. We have sessions on how to create ETL pipelines, work with databases, different kind of files, how to work with AWS. All of those things are also there. These things are mostly data engineering focused, right? They will not ask these things in interview, but in your day-to-day work you will have to do all of these things, right? Interview will focus on from here, from second lecture till I think pandas, right? Maximum till here, right? All of these things are your day-to-day work that you have to apply, right? So it is an end-to-end project which will really help you in getting your Python hands-on and feeling confident, right? You can see the reviews as well. We have very good reviews for this course, and all are organic reviews. I don't ask anyone to give some good reviews or fake reviews, right? So you can check it out. And okay, so once you are comfortable with these things in Python, then there are different patterns on which questions can be there in your interview, right? So this is very common pattern, like you have a dictionary and you have to count something, right? We will see a lot of examples on that. Then there are problems on array plus dictionary, right? When I say array, in Python, arrays are list basically, right? So array and list is the same thing. So if I am saying array or list, they are both same thing. Similarly, dictionary and hash map, it is the same thing, right? In Python, we call it dictionaries. In some other languages like Java, they are hash map, but they are the same thing. Okay, then we have string problems, right? So there are a lot of questions asked about string, how to work with string, and there will be a good question where you have to manipulate string and do a lot of things, right? Then you should know what is binary search, right? What is two pointers? So some problems can be easily solved using two pointers. Without two pointers, the solution will not be optimized. But with two pointers approach, we can have a better efficient solution. Then we have set based problems, right? Sliding window, sorting, reversal, and then parsing logs. This is specifically for data engineers, right? How to parse logs, how to get some information from the logs. So these are the important topics, right? That we need to solve problems on, right? So I will start with the basic things and then I will move forward with more things. Now, I'm not going to cover these things, right? I will talk about time complexity, right? Because when I'm solving questions, I have to tell you, okay, this is the time complexity, and if you solve this way, this is the time complexity. So when I'm solving questions, that time I will tell you what is time complexity and how to go about it, how to think about time complexity. Okay. So these are the things, these are most important and cover 90% of the interviews, right? So you should be good after finishing this video. Okay. Now, second thing is analytics. Now, in analytics, basically for data analysts, some questions can be asked on pandas, right? And maybe data engineer, but this portion is typically rare, right? Most of the companies, product-based companies, service-based companies will focus on these things because as a data engineer, you will not be working on pandas mostly. You will be working on maybe PySpark, right? But you should know it. I mean, working with pandas, you should know it. A lot of organization still uses it, but I don't think many of the interviews ask this. They can ask, but I'm telling you, mostly they are not asked. Mostly it is around these two topics, right? These are the topics and these are the patterns. Now in pandas, also we have few things that you should focus on if you are learning pandas, right? Group by aggregation, filtering, sorting and top n, merging or joins, how to write ETLs using pandas, window rank functions, right? In this video, I will not cover this. If you think there is a good amount of interviews which are asking these things, I can create a separate video, right? But I want to focus on the most important 90% of the things, right? So we will focus on these things today, right? And maybe in the next video, I can talk about this if there is a good amount of requirement in the comment section. Okay, I hope this is clear. Let's start with the practice sessions. Okay, so let's understand what is time complexity, right? Let's read the definition and then I will break it down step by step. So, time complexity is a way to measure how the number of operations in an algorithm or program, you can write anything, right, grows as the input size increases. It does not represent actual time taken, but how efficiently an algorithm scales. It helps compare algorithm independent of machine speed or programming language. Now, a lot of people think that time complexity means the time taken by a program, which is wrong because time taken by a program is dependent on machine, right? If you are running a Python program or any program on, let's say, 8 GB machine, it will take some amount of time. But if the same program you run on, let's say 16 GB or 32 GB machine, then it will take less time, right? So the time taken by a program is not fixed. It is dependent on machine. But time complexity we measure independent of machine, right? It does not represent actual time taken, but how efficiently an algorithm scales, right? So this thing should be clear, right? That time complexity is independent of a machine speed or which programming language we talk about, right? We just a relative measure to check how good my program is. So we will understand with a simple example first, right? So let me move on to Visual Studio, and I'll explain in a very intuitive way. Let's say you have this array, right? Array or list. In generally most of the programming languages, you say array. In Python, it is a list, right? List is a group of elements together, right? So we have 1, 2, 3, 4, 5, 6. Okay. So this is my input, right? This is my input. This array is my input. Let's say I want to find sum of all the elements of this array, right? So what I have to do, I have to start with this, then go to this, then add this, then add this, then add this, then add this. So if there are six element, I will have to do six operations, right? So let's write a program. So let's say my sum is, or let's define a function, define get sum, right? And it will take one array as input, right? So what we will say, we will initialize my total sum. So I will say total sum equal to 0. Right. Now I will run a loop over it, right? Because I want to go to each element. So what I want to do, I want to run a loop over this list, right? I want to go over, iterate over this loop and go to each element and sum all the numbers. So I will say for num in, right, add, and then I will say total sum, right, equal to whatever was sum was there earlier plus this num, whatever num I get, right? So I'm getting 1, 2, 3, 4, 5, 6, right? And I will just run over it and then I will say return my total sum. I hope you understand this. So I want to see how many times I'm doing this operation, right? So I'll say print and I will just call this function now. So I'll say get sum and I will pass array, this array, whatever we have declared here, right? And let's see. Okay, so it is giving me 21. So if you sum all of this, it will give you 21. Now, how many times we are running the loop or how many times we are doing this operation, right? So let me print it. So I will say iteration. We will see how many iteration are there. Iteration equal to 0, right? And then in the loop, I will say iteration equal to iteration plus 1. And then I will say print iteration and then iteration. Right? I'm just showing you how many times we are running this loop. So if you see iteration 1, 2, 3, 4, 5, 6, right? So there are six elements. I'm running this loop six times. So I'm doing six operations, right? Let's say if I increase one more element here, right? So how many times this will run? Seven times. Which means as the size of my input is increasing, the number of operations are increasing linearly. Linearly means if there are eight elements, then number of operations are eight. I am doing eight operations. If it is nine, then nine operations. If it is 1 million, let's say in this array I have 1 million elements, then I will run this loop on 1 million elements and there will be 1 million operations, right? So this is known as a linear time complexity. We represent time complexity by big O notation O and then N. Right? So this is N means linear time complexity. As you increase the size of the input in the same proportion, your number of operations will increase, right? Now it is irrespective of machine, right? The way we are calculating this complexity, big O N, is irrespective of machine, right? We are saying as the number of input size is increasing, is the number of operation increasing? Now it will be true for 8 GB system or 16 GB system or for Java or Python or any language, right? So this is why this is platform or program and speed independent, right? This is how we calculate the time complexity. Great. So if I go back here, it is saying ON is linear time, right? So our example is loop over the list. So you can draw a chart, right? So if you see this chart, so on the x-axis, I am saying input data size, right? As the size of the input data increasing, how the number of operations are increasing. So in case of linear time complexity, right, ON, this is linear. So as the input size increasing, in the same manner, my number of operations are increasing. So if you see, this is x equal to y, right? The number of input data size equal to number of operations. So this is the x equal to y line on your chart, right? So this is your ON, right? Lesser the time complexity, better your program is, right? Now let's take another example. So this we understand. Now let's say my requirement is I want to get the first element of my array. So this is my array, right? Let me just comment this. So this is my array and I want just the first element of the list. So what I will do, L and first element will be 0, right? And I will print this. So let's print it. Okay. So if you see, I am getting 1. So this is giving me the first element. Now let's say I increase the number of elements in my array, right? Now if I again done this, I'm always doing one operations. It doesn't matter how many elements are there in my list, right? The number of operations will be just one, get the first element of the list. So this is known as constant time complexity, that the time taken or the number of operations done by your program is fixed irrespective of how small or big your input is, right? So this is known as O1. It will take fixed O1 time, right? So this is your constant time complexity where it is constant irrespective of input size. And if you look at the chart, this is my O1, right? This is flat. Doesn't matter that how big is your input data size. If we keep increasing, the number of operations is constant, which is 1. So there will be only one operation. So this is known as constant time accessing an index in a list, right? So this is your O1, ON. So O1 is better than ON, right? Because it will just one operation, right? So always if you go up, it is the worst time complexity, down it is the best. So O1 is best and after that ON. We will talk about other time complexities as well, right? Now let's take another example of ON, right? Let's say I have this array now, right? Now, what I want to do, right? This can be a sorted or unsorted array, right? Let's not take it sorted. So let's take it 15, 11, 12, something. Okay. Now, what I want to do, I want to find index of a particular number, right? Let's say someone is tell me where is 15, right? On what index 15 is there, right? So my target is this, that I want to find index of 15 in my list. So how I will do it? Let's write a program. So I will say def find index, right? It will take two input. One is array and another is target, right? What you want to search. This is also known as linear search. So I'll just explain about it. So what I'm saying, that okay, loop over it and check wherever the target is. So I'll say for, let's take I in range, right? These things you should know already. Length of array, right? So I'm saying if li, right, is equal to target value, right? Whatever target I have, then return that index value, right? That's it. So this is my linear search. You can call it linear search. I'll tell you what is linear search. Linear search. Okay. Now we will see. What is the time complexity of this? Okay. So now I will just call this, I'll say linear search, and let's call, I'm passing array, right? And my target, right? Great. So let's print it. So target is 13. The target element, let's call it target element. And I'll just pass this here. Okay, let's see what it will give me. Okay, so it is giving me 9, right? 9 means, so if you count here 0, 1, 2, 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So it is at ninth index, right? So the 15 is at ninth index. Now let's say I search for 7. So so it will give me, where is 7? 7 is at sixth index. Great. Now let's say how many iterations we are doing here. So again, we are running, we are comparing this. So this is one operation, right? We are running this inside for loop. So I will say iteration equal to 0, right? And then iteration equal to iteration plus 1. And I'll just print iteration. Okay, let's run this. So if you see, this is running 6 iterations, right? Uh, da, 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 da. Okay, it has to be outside the loop. My bad. Okay, so initialization is outside the loop, and then okay, it has to be outside actually if condition, because only it will print only when we satisfy the condition, right? So iteration equal to iteration plus 1. Great. Uh, okay, print is again here. So let me just fix this. Okay, so if you see 1, 2, 3, 4, 5, 6, 7, so it is running 7 times, right? So now if you see, the number of operations is dependent on where my element is. If I just, let's say, search for 2, right? So it will run only 2 times. Iteration 1, iteration 2. So there are only 2 operations, right? Now how I will tell what is the time complexity, right? Time complexity depends on that which element you are searching. If you are searching for 2 here in this list, then it is at second element only 2 operations, right? If I search, let's say, 11, then it will run maybe 8 or 9 times, right? So when we talk about big O notation, we consider the worst time complexity. Worst means if someone is searching 12, that is the worst case, right? When someone is searching 12, that time we have to run over the full list, right? So if I run this, it is running 12 times, right? So when I talk about a big O notation, it means we are considering the worst time complexity. That at the worst, how many operations I have to do. So again, this is a ON, because if the number of elements are increasing, if it is 15, then my worst will be one more operation. Right? So it is running 10 times. If I increase one more, right, let's say 20, and again, so it is again 10 times, right? So it is running 10 times. If I make it 20, this is my worst time complexity, which will be 14, right? We have to go till here, right? So whenever you think that what is the time complexity of this program, you have to take the worst case. In best case, it will be O1, right? Because maybe every time you find the first element, right? Someone is searching 1, right? You will get in the first iteration itself. But you have to consider the worst time complexity, and in this case, it will be ON, right? So this comes into the category of linear search, that we are searching a element linearly, right? Linear means first element, then we check second element, then third, then fourth, then fifth, then sixth, and so on, right? So this is your linear search. Great. Now let's move on to the next time complexity, right? Which is, let's talk about ON square, right? Then we will move on to the log n. So what is ON square? Quadratic time. Generally, when you have to run the nested loops, right? Loop over loop, that time this quadratic comes into picture, and it is very bad kind of time complexity, right? Because as the input size increases, your number of operations will increase square of times, right? So for example, if you are increasing from 10 to 11, then maybe your operations are increasing from, let's say, 10 to 100, right? I'm just giving one example, right? So let's understand that. So I've written a simple program to find a duplicate transactions, right? So let's say you have a this transactions, you have a array, right? And then what you have to do, you have to find the duplicate transactions. So what I have to do, for example, 101, 101, these are duplicates. So I have to get the index of these. So let me run this and show you. Okay, so I'm getting answer as 0 to 1 4. So it is telling at index 0 and index 2, they are duplicates. Similarly, at index 1 and index 4, they are duplicates, right? So this is what it is returning. List of tuples. Great. So let's think about it. How do we solve this problem? So what I have to do, I have to pick first element with a very brute force method, right? First element and compare with all the elements, right? So 101, 203, 101, 404, 203. So this element I will pick and compare with all the elements. Then in the second iteration, I will pick this element and compare with all other elements. In the third iteration, 101, and then I will compare with other elements, right? So this is what we have to do. So this is a loop under loop, right? So this is a nested loop. So I'm running a loop on this list first. So if you see on transaction, and then again I'm running on the another loop on transactions and comparing, right? I'm not going to explain this program, but basically we have to run loop two times, right? Whenever you see two times loop, mostly it is a O n square time complexity, right? Let's see how many iterations we have to run. So I'll say iterations equal to 0, right? And we will say iteration equal to iteration plus 1. Now I will, so all the operations we are doing inside the second lasted loop, right? So I have to print here, right? So for every element in outer loop, inner loop will run, right? So all the operations are happening within the inner loop. I'll say iterations plus 1, and let's print it. Print iteration. Great. So if you see, I'm doing 10 iterations, right? I'm doing 10 iterations for this program. Now let's increase the size of my transaction. Let's say I increase one more, let's say 100. Now what will happen? In each loop, I have to iterate one more time. So when 101 was comparing, it was comparing with four elements. Now it has to compare with five elements. Again, when 203 I was comparing, earlier I was comparing with three elements. Now I have to compare with four elements, right? So as the number of input is increases, it will run loop more number of times, right? So let's see. So there are 10 iterations and I increased one more element. So if you see, now we have 15 iterations, right? It is not linear that if I increase one element, then only one operation will increase. No, let me increase one more. Right? Let's say 101. 101 is already there. That's fine. 1110, right? Anything. So from 15, we will see it is going to 21, right? So this kind of cases where you have loop under loop, or you have a matrix, right? Let's say you have a matrix. Let's say 1 2, so this is the first element of your matrix, second, third, then you have, let's say, 4 5 6, right? And then 7 8 9, right? If you have a matrix n by n, right? And you have to loop over it, right? So three rows and three columns, so there will be nine elements, right? So it will be O n square. You will have to run your loop O n square. If you want to traverse over this matrix, then you have to run n into n times, right? So this is where your O n square comes into picture, and this is worse than your linear time complexity, right? Because in this, as the input size is increasing, this is increasing quadratic time, right? If you increase 3, then maybe it is 9. If it is 4, then it becomes 16, right? So your best is so far O1 because it is constant, then you have On, and then On square. The whole purpose of our Python programs will be that if we can solve our question with less time complexity, If we can solve this with O1, then great. If not, then ON. If not, then ON square. Most of the Python problems you want to solve with ON or O log n. Right? So we will see what is O log n, and then we will come back to it and we'll discuss the final thing. Okay, so what is O log n, right? O log n is a time complexity where the number of input size when you increase, then the number of operations also increase, but very, very slow, right? It is not like on, that if you have, let's say, 10, then operations will be 10. If you have 10 size of your input data, then 10 operations. No, maybe if you have 10, it might be, let's say, 2 operations. When it is 100, then might be 6 operations, right? So it is logarithmic, which means as the input data size is increasing, this is also increasing, but very slow, right? So let's see how we can visualize this. Okay, so there's a concept of binary search, right? In SQL also, if you have learned index, you will know how binary search works. So how binary search works, let's say you have an array. I'm just explaining how this works, right? Let's say you have an array and it is sorted. Sorted means we know that it will be in a ascending order or descending order. So in our case, if you see, this is in ascending order: 1, 3, 5, 7, 8, 10, 13. So this is the requirement, right? That my array is sorted. Let's say my array is sorted. However we sorted it, it doesn't matter, but we are getting an array which is sorted. Now I want to find an element in this, right? One is we do a linear search, whatever we did here. We go to the each element and search it first, second, third, and wherever we find it, we are done. But because my data is sorted, I can do a binary search. Right? Now, what is binary search? Binary search means, let's say someone is telling me, so we have 7 elements in this, right? Someone is telling me that find where is, let's say, 3, or let's say 10. So I want the index of 10, right? So one way is linear search, we all know. But let's see how we can do with binary search. So what I will do, I will go to the mid of this array. So mid of this array is 7, right? Mid of this array is 7, and I will compare that if this element is equal to 7 or not, right? If it is not, then I will see if it is greater or less than my mid element. Now 10 is greater than my mid element. My mid element is 7 and 10 is greater than my mid element, which means 10 will be somewhere in the right? Because this is a sorted. So I'm checking with the mid element, my target element. I want to see where this 10. So I will check with the mid element 7, right? And 10 is greater than 7, which means that 10 will be somewhere in the right. So I can skip all these left element. I don't have to search. So I will search in 8, 10, 13. Again, I will take mid of it and I will check, okay, if 10 is equal to mid, yeah, mid is 10, so I will return that value, right? Let's take another example. Let's say 1. I want to search 1. So I will check with the mid element, right? If it is equal to mid element, I will return that. If it is, no. Now, if it is less or more, if it is less, then I will ignore these things. I'll just look into this. Great. Now again, I will take mid. If it is equal, no. If it is less, then I will come here and then I will again compare. Then I will return this. Right. So basically, I'm doing a binary search, right? I'm not iterating over all the elements. I will just divide it, check with the mid element. Then every time my input size is becoming half and half and half, right? So let's take this example, right? So I've written this program for binary search. I'm not going to explain today. You can learn about it. But basically, let's see how many iterations we are doing, right? So I'm saying iteration 0 and iteration equal to iteration plus 1, same thing, right? And let's see how many iterations we will do. So I'm just running it. So if you see, it is doing the 3 iterations, right? I'm trying to find 1. My target element is 1, so it is returning 0, right? And 3 iterations it is doing. So I have 7 elements, iterations are 3. Great. Now let's add some more elements. It should be sorted. So I'll say, let's say 20, 21, 30, 33, 40, 50, 70. I just increased so many elements, right? So we had till 10, I think 7 were there. Now we have 1, 2, 3, 4, 5, 6, 7. Okay, I increased 1, 2, 3, 4, 5, 6, 7, 8. I added 8 more elements. So we have 15 elements now. And we will see how many iterations are happening to reach to see where is 1. Right? I'll just run it. You see, only 4 iterations are happening. So input size increased almost double from 7 to 8, but iteration increased by only 1. Let's search for something else. Let's say I'm searching for 70. Right? So if I search for 70, there are only 3 iterations, right? On the third iteration, it is able to find out, right? If I increase more, let's say 101, 102, 103, right? Again, it is just 2 iterations. It depends on where is your this element, but it will be increasing by very less number of operations are increasing because we are dividing into half, right? If there are 100 elements, we are dividing into 50 first, then 25, then 12, then 6, and then 3, and then 1, right? So we are not doing 100 operations, just we are doing a binary search, right? So you can think about something like this is your binary search, right? We look at the middle element. If my target element is less than middle element, I will go in the left. If my target element is greater than my middle element, I will go to the right, right? And then again, I will keep doing it until I find my final element, final target, right? So this is your log n. So capital O log n or logarithmic time complexity, right? So this is your log n. If you see, as the input data size is increasing, it is increasing but very slowly, right? As you have very big size, 1 million, it is almost getting flat, right? So this is your logarithmic time complexity. Example is binary search, right? So there are other type of complexities as well, like 2n and factorial and all. But these are the main ones that we need to understand. And in fact, on square also we will be avoiding it most of the times. Right? Most of the times our solution should be in on. Right? I hope this makes sense. Now, last thing I want to tell, or two more things I want to tell is, one is when I sort something, right? So uh, let's go here, or it is fine. Let's go here. Let's say this is my array, right? Or this is my array transactions. Let me comment it. And I want to sort this array, right? So I will say transactions dot sort, right? And then I will say print transactions. Okay. And I will print again here. Okay. So let's see what will happen. So if you see, this is here. And now this is sorted. So 100, 101, 101, 1203 and all. Now this is inbuilt method of sort, right? But we need to understand that how much time it will take, right? What is the time complexity of this sorting? So when I'm doing a sorting, Python is doing some operations internally, yeah, right? There are different kind of sorting algorithm, right? But when we are doing this sort, this takes big O n log n time complexity, n log n. So this will be your n log n time complexity, which will be better than n square, right? But worse than on. So it will be somewhere here between o n log n, right? It will take more than n operations, but better than o n square. So your o n log n will be somewhere here. Right? So your this is how it is. So for example, if I want to find, let's say, largest element or smallest element in this transaction, right? So what I can do, I can sort it, and then if I want the smallest, I will take the first element, right? So I will say sort and then transaction 0. So my requirement is I want the smallest element in my array. So what I can do, I can do transaction dot sort, and then once it is sorted, then I will take the first element, and that will be my smallest element, right? So if I just run this, so this is my smallest element, right? But if you look at the time complexity, so this is O1, right? So to get the first element, it is O1, O1, right? But to sort it, it is O,
log n log n, right? So when we have two time complexities like this, that this is taking so we have two operations. One is taking O n log n, and another one is taking O1. So we take the worst one, right? So the total time complexity we will take it as O n log n for this program, right? Sorting plus getting the first element, the overall will be considered as O n log n, right? So if you have two operations, one with one time complexity, let's say it was O n, and another n log n. So overall we will say n log n, right? So whatever is the worst, that one will be considered, right? So this problem we solve with O n log n. But can we make it better? Can we make this program so that it takes only one iteration and only can we solve it on, right? So we will solve this question next time in the next video. But basically the idea is you should know that sorting is costlier than on. You should know that when you are sorting something, it is costly than on, right? So your on log n will be somewhere here. Okay, great. So hope you understand it. So generally people will just sort the data, right? And they will say, okay, I solved it. But if you can solve it without sorting with on time complexity, that will be best. Great. Now, last thing I want to discuss is dictionary, right? So when I do a lookup in a dictionary, so let's say I have my dictionary, sorry, let's say I'm saying employee ID and name, Ankit. So this is my key value pair, right? Another value pair is, let's say, 200, and value is Amit, right? Now this is my dictionary, right? Now when I do a lookup on a dictionary, basically let's say I want what is the name of ID 100. So I will say print my dictionary, right? And I will pass 100, right? Right. So let's run this. So if you say it is giving me Ankit, right? It is giving me Ankit. Let me comment this everything. Okay. So let's run this again. So if you see, I am getting Ankit. So what it is doing, we are doing a lookup. I am saying, give me the value of key 100. Right? This is my key value, key value. Now you must be thinking that internally this is running a loop, right? Because it will go to first element and see if it is 100 or not. Then it will go to second element, then see if it is 100 or not. Then it will go to the third element. Let's say if they are 1 million. You must be thinking it may be doing a linear search, but that's not the case, right? When you do a lookup on a dictionary, it is a O1 time complexity. O1 constant. How? So what happens when you create a dictionary? It in memory, right? It has the all the values, which means Python will know that at what address in your memory 100 is, at what address 200 is. So when you say my dictionary 100, it will directly go to that address and give you the value. When you say 200, it already know, it has hashed all the keys, so it knows that 200 is where in your memory, right? So it will just go there and give you Amit, right? So this is a constant time complexity when you do a lookup on a dictionary, right? So this thing you have to remember, right? So any lookup on a dictionary is O1 constant time complexity. Great.
Now that you understand time complexity, let's solve few more questions. So let's say I have an array or list and we have some elements and that are unsorted. This is not in sorted order, right? Now my requirement is I want to find the largest element or the smallest element, anything. So we will solve for the largest element. The thing will be same for the smallest element as well. Now, how do I find the largest element? Let me make, okay, so 40 is largest in this case. Okay. So how do I find it, right? So one way is very brute force ways. I sort this array. So I'll say array dot sort, right? So once I do it, your array will be sorted. So if I say print array, right? And you see your array is sorted here, right? 1, 9, 12, so on and so forth, right? Now I can just take the last element, right? Once it is sorted, the largest element will be at the end, right? So I can just say air and give me the last element. So I can do negative indexing and that will give me 40, right? But if you see, what is the time complexity, right? So time complexity will be O n log n, right? Because sorting takes what? N log n, right? And this is not the best solution, right? N log n, okay. Okay, so what else we can do, right? So it is O n log n to sort it, and to get this element will be O1, right? Because this is fixed. No matter what is the size of your array, if you get the last element, that will be O1. So overall time complexity will be O n log n, right? Now the whole point is, can we make it better, right? Instead of O n log n, can we make it O n, right? Can we make it O n? So let's see, can we make it or not? Okay, so what I will do, I will start iterating over this list, right? And I will keep track of the largest element. If a next element is largest, I will replace the variable with the largest one. Okay, confusing? It's okay. I'll explain you. So what I'll say, I'll write a function. So define get largest number, right? Let's say this is the function I'm defining, and it will take a array as input, right? And I'll say, right, so I'll say largest element, or let's say max num, is the first element. I'm just assuming that first element is largest, so I will say air 0, right? Okay, so currently this is my first element, and I have stored max num as first element, which is 20. Now I will iterate over it. I will check second element. If it is greater than this, then I will assign max num to this number. Then again this, then again this, and I will keep doing it. So what I'll do, I'll say for num in, right? For num in this array, right? If num is greater than max num, right? In that case, I will say my max num is this num. You're getting it? Okay, so let me tell you what is happening. So first element is 20, and in max num currently 20 is there, right? I'll just write it, right? So in max num 20 is there. Now I will iterate over it. So first element is 20, right? Is 20 greater than 20? No, right? I can start with the first element also, but it is fine, right? Because first element anyway we are taking in max num. Okay, so this will not go inside it, right? So it will be as it is. So my max num will be 20 after first iteration. Now after second iteration, 12, right? Is 12 greater than 20? No. So again it will not go. So we will not do anything. Again 18. Is 18 greater than my max num? Max num is 20. No. Then it will keep going on like that. Let me take this as 21, right? Okay. Now in the next iteration, it will be 21, right? So is 21 greater than max num? Yes, 21 is greater than max num. At that point, my max num will become 21, right? My max num will become 21, right? And that way, in the next iteration, 30. Now 30 is num, right? 30 is greater than my max num. Yes, then it will become 30. And then at 40 it will become 40, and after that it will never replace it, because 1 will be less than max num, right? And 9 will be less than max num, and 30 will be less than max num. So my max num will remain as 40 at the end, right? So I have to come out of this loop, and I will say return 40, sorry, return max num, right? So if you see the time complexity here, right? Here, if you see, I am just running loop once, right? So if there are 1, 2, 3, 4, 5, 6, 7, 8, 9 elements, this loop will run 9 times, and I am doing 9 operations. This is one operation, so again O1, and this is On. So overall will be On. So On is better than O n log n, right? So this is how you have to think about it. Let me call this function and show you. So I'll just say print, and I'm passing this array, right? So let me pass array. So if you see, I'm getting 40, right? So this is how you have to think about it. Let me just remove this because it is sorted already. Yeah, now it should be fine, and we are still getting 40, right? Let me clear it, and what I want to show it, I will print here as well, so that you know after every for loop where we are, right? So I'll just say print of here, right? Print. So we are within for loop outside if condition, right? So if condition is satisfied or not, I always want to print what is my max num value, right? So let me see what it will give. Okay, so it is saying 20. So initially max num is 20. Then in second iteration also 20. Third iteration also 20, right? Now in the fourth iteration, if you see, it became 21. Now in fifth it became 30, right? Then it became 40, and after that 40 is there always max num, because we are doing comparison only when the num is greater than max num, then we are replacing it, otherwise it will remain as it is, right? So this is how you have to think about it. Okay, great. So now let's solve next question, where instead of largest element I need to find the second largest element, right? So this is my array, right? In this, if you see, the second largest is after 40, it is 30, so we should get 30. Now again think about it, right? If I need second largest element, the easiest way, again I can just sort it, right? So let me take it here, right? I will sort it and get the second last element, isn't it? I will sort it and get the second last element, and I will get second largest value, right? Let me just comment this for now. And if you see, I got 30, right? Because it will sort first. After sorting, that 30 will be here and it will give me. But again, the time complexity is n log n, sorry, n log n, right? Right? So sorting takes n log n time complexity. So again, I want to solve it with log n, right? For the better efficient solution. Okay. So now think about it. Here we were maintaining a variable max number, and we were checking each number. If it is greater than max number, then we were replacing the value of max number, and that we checked for all the values. Now here we have to keep track of two variables, which is largest and which is second largest, right? So let's do it. So I'll just remove it for now, right? And let me take this function. Okay, so I will call it get second largest number. Sorry. Okay. Now what we will do, we have to declare two variables now. One is max and one is, let's say, second max num, right? So this will be my largest element and this will be my second largest element, right? For now, right? For now, I am just keeping it as 0, 1 and 0. I'll not hard code it, but just to explain what I'm trying to do, for now I'm keeping it as 1 and this is 0, and this is maybe I don't want to keep it 1, let's say 3. Right? I'll tell you why I'm doing. So for now, consider this is my array, right? And these are two numbers. I just declared max equal to 1 and second max is 0 for now, right? We will not hard code it, because in my array I can have 0, 1 or negative numbers as well. But for this example, let's say I know my smallest value is 3 here. So I'm just keeping it as 1 and 0, right? I'll change it later. Now what I will do, now I will check each number with max num, right? If number is greater than max num, right? If my number, so first number is 20. Is it greater than max num? Yes. So now my max num will become num. At the same time, my second largest number will also change, right? Initially, my largest is 1, second largest is 0. Now, my largest number will become 20, right? And what will be my second largest now? Second largest will be whatever value of the max num, right? So my second largest will be 1 now, right? So you have to remember it. If I am getting a number which is greater than my maximum number, so my largest number will become 20 and second largest will be whatever was max earlier, which is 1, right? So before assigning this value, right? So this will become 20. So I don't have information about what was my max num, right? If I assign it, my max num will become 20, right? Now at this point, I don't know what was my earlier max num. So before assigning it, I will say my second maximum equal to maximum, right? My second maximum equal to maximum and maximum 20, right? At this point, the maximum will become 20 and second maximum will be 1, right? So this is how you have to keep track of it. Okay, great. So this will solve one problem. Now there is another problem. Let's see the second iteration and we will see what is the issue here. Let me remove it for now. Now in second iteration is 12. Let's see what will happen. Now 12, right? 12 is greater than maximum? No. 12 is not greater than maximum. My maximum is what? 20, right? So is 12 greater than 20? No. So it will not go inside it. But if you see, my second maximum is what? 1, right? This should be updated, isn't it? See, maximum will not be updated because maximum is 20 and second maximum is 1 currently, right? If you see, second maximum is 1. But 12 is greater than 1, right? So my maximum should not be updated at this point, but second maximum should be updated. That means second best maximum is 12. So I have to put one more condition here. If num is greater than second maximum, right? If my number is greater than second maximum, then I will say my second maximum is equal to num. Now what will happen? If it will not go in this if condition, it will go in elif and check if is it 12 is greater than my second maximum, which was 1. Yes, then update it, right? Now I have the track of maximum and second maximum properly, right? And let me return these two. So I'll return maximum as well as second maximum, right? And let me call this function now, right? Now remember, this return will be after for. So after all the iterations are over, whatever the values of maximum and second maximum at this point, I want to print it, right? So I want to get I want to return it to the function, right? Let me call this. Okay, so second largest number. Instead of that, I will do this, right? And this is my array that I'm passing, and let's run this. Okay, so I'm getting 40 and 30. Let me clear it once and I will again run it. So if you see, largest is 40 and second largest is 30, right? So the function is get second largest element. I can just get this one, right? I'm just showing you, right, that this is my maximum and second maximum. In question, if you are getting, you have to just do this. Okay, I hope this makes sense. Now there is one problem in this solution still. Let's say I have another value as 40. Right? Let's say another value as 40. Right? So I have 40 42 times and then 30. Now expectation is I should get 40 and 30 still, right? My expectation is the highest number should be 40 and next second highest should be 30, right? Let me run this and see what will happen. Okay, I am getting 40 and 42 times, right? Why? Because if you see, it is checking if num is greater than second maximum. So when it is coming here at the last iteration, right, the highest element was 40, right, and second highest was 30, right, till here, you can imagine, right, till here. Now when I reach 40, it will check, is it greater than maximum? No. Is it greater than second maximum? Definitely. So it will replace the value, and that's the problem. So in elif, I want to make sure this num is not equal to the maximum. So I'll put one more condition, and num should not be equal to maximum. Then I will not have problem, right? So let me just remove this, and one more time I will run this. Now if you see, I am getting right value 40 30. And what is the time complexity now? This is a for loop. We are running the loop one time over the array, right? So it is on now, right? So if there are n elements, we'll be doing the n operations, right? So we again improve the solution. Instead of n log n, I'm solving it with on. Okay, great. Thing is here that we cannot hard code this 1 and 0, right? I just put it 1 and 0 so that I can explain you, but we should initialize it with a negative number, a big negative. So I will say minus infinity, right? So anything will be greater than this, right? So my initialization will be a big negative number. So everything will be greater than this, and I can easily find my first highest and second highest, right? And this all finds. Okay, great. So let's solve a next question. In this question, let me first comment this. My requirement is, let's say I have an array, right? Let's say this is my array, nums equal to 2, 3, 4, 2, 3, 5. I want to find first non-repeating element, right? First non-repeating element in my list, in array or list, right? So what does that mean? If you see, we will start from left, first not repeating. So 2 is repeating or not? Yes, 2 is repeating. 2 is here as well as here. 3 is repeating? Yes, 3 is repeating. Okay, 4 is repeating? No, 4 is not repeating. And 5 is also not repeating, right? But what I want? First non-repeating. So my answer will be 4. 4 and 5 both are non-repeating, but in array, whatever comes first out of all those non-repeating element, I have to give that. So answer will be 4, right? So let's see how we can solve this. So one brute force method is, let's say what I will do, right? I will create nums, and let's say I will create one more nums1, right? I'm just telling you how you will do it, right? I mean, I don't have to create it. I can use it again, nums 2 times in my program, but just to explain you. So I will pick first element, right? And I will check if it is there or not in this, right? If it is there, right? So I will check 2. I will not check the first element, and I will check in remaining. If it is there, then this is not a not repeating element. This is a repeating element basically. So I will discard 2. Then again I will pick 3, right? And I will check 3 if it is there or not. If it is there again, then this is not a non-repeating element. Again I will pick 4, and then again I will check in rest of the array, right? If I'm at index 3, I will check from index 4 from that array, right? Similarly, when I'm at 5, I will check going forward, right? Okay, great. So the problem here is that it will be O n square time complexity. And this is a brute force method. It will be O n square because you are running a loop inside a loop. So for each element of this array, you are running a loop on this array. Each element of this array, you are running a loop on this array, right? So this will be a brute force method. You can solve it, get the right answer, but not the efficient one. So we will see how we can write a efficient code for this. So what we will do, right? Let me remove it now. I don't need 2 arrays, right? As such. So what I will do, I will get frequency of each element first. That how many times 2 is there, how many times 3 is there, how many times 4 is there. Once I have that frequency, then I will check from this array which is that first element whose frequency is just 1, right? So let's go step by step. So I'll write a function, define first non-repeating, right? So most of the time you have to write a function. It is not that you have to write a code directly. You have to write a function always, right? Okay, so what it will take? It will take a array. That's it. We'll get the array, and then we have to find first non-repeating element. Okay, so I will define a dictionary, right? Frequency, and it will be initially empty. Okay, great. Now, before I write the solution, I want to tell you something about dictionary, right? So let's say you have a dictionary. So you have a dictionary, let's say frequency equal to, and I will create some key value pair. Let's say Ankit, right? And it's his age, right? Or let's say employee ID 1 and its name Ankit. Let's say this is better example. Okay, so let's say this is your dictionary. Now you want to see the value of the element in this dictionary. So what you will say? You will say frequency of 1, right? And if you just print it, it will give you. Okay, so if I just run this, frequency, okay, I have to give in double quotes, or let me make it like this. Okay. Okay, so it is giving me Ankit, which is correct, right? Let me clear it once. Okay, so I'm saying what is the value of 1 frequency, and I will pass the key value, right? And it will give me the value of this. So I will pass the key in this dictionary, and it will give me the value. Now if I pass some other key, let's say 2, right? Now 2 is not there. What will happen? It will give me error. So 2 is not there, right? Now there is a more sophisticated way. So instead of directly saying that give me the value of this key, you can say give me frequency dot get, and you will pass the value. So you will say give me the value of 1, right? And let's see what will happen now. So I'll say print. So get is a function I'm using, a dictionary method you can say, right? And let me run this. So I'm again passing 1 and it should give me Ankit, right? And this is perfectly fine, right? This is giving me Ankit, so there is no issue. Now advantage here is if I pass a key which is not there, it won't fail, right? So if I say, sorry, clear that. So if I say, let's say 2, right? So it will not fail, it will just return none. So my program is not failing, right? I don't want program to fail when some key is not there. I'm just saying none. You can pass an argument that if it is not there, then default it to something. So I will default it to 0, then it will give me 0. Right? So this is a more sophisticated way. If something is not there, it's fine, give me 0, right? And if it is there, give me that value, right? So this works fine. Okay. Now let me write the function. I hope you understand this, right? So let me comment it so that I can refer it back if required. And let me go back here and I'm going to write this. So initially I'm initializing my dictionary frequency equal to empty dictionary. Now I will run a loop for num in nums, right? So I'm running a loop for num in nums. Now what I will do, I will say frequency. So how to add an element in a dictionary? I can just pass a value num, right, equal to frequency of num, right? So I will get it. What is the value of, so in this what I want to keep ultimately? In this I want to keep the frequency of everything. So I will say 2 is 2 times, right? And 3 is 2 times, and 4 is 1 times, and 5 is 1 time. This is what I want to keep in this, right? So what we will do now? So I'm just checking that if it is there already, then add 1 in this, right? Right? So if, so okay, so let me do this. So what I'll say frequency dot get, right? What you get? Num. If num is there, if not, then make it 0 plus 1, right? So what I'm saying, that check if num is there or not in this dictionary, right? If num is there, so initially in the first loop what will happen, right? Num is there or not, 2 is there or not in this dictionary. Initially it is empty, right? So it is not there, so it will give me 0 and I will increase the count by 1. So at this point our entry will go and it will say 2:1 in my dictionary, right? So I'll just write it in my dictionary, right? There will be a entry which will say 2:1, right? This is how you have to do it. And the next station 3 will come, right? Again for 3, right? Is 3 there? No, 3 is not there. So again it will become 0 plus 1. So there will be one more entry. It will say for 3 the key value pair is this. So this is key, this is value. This is key, this is value. Now for the third iteration again 4 will come and there will be one more entry, 4:1. Okay. Now in the next iteration what will happen? It will 2 will come again, right? Now it will check if 2 is there. Yeah, 2 is there. What is the value? 1. So it will get 1 and plus 1. So it will make it 2. Right? Again it will check if 3 is there or not. So 3 is there. Yes, 3 is there. So add 1. So this will become 2. Next it will check 5. 5 is there? No. So again it will default it to 0 plus 1 and there will be a one more entry, 5:1. Right? So let me run this and show you. So I'll just say return this dictionary. So this is my dictionary basically, right? And let me call this. So I'll just say print and first non-repeating character, and it will take just one argument, and let's see what it returns. So if you say, it is returning me the same thing, 2, 2, 324151. So basically I get the frequency of each element in this list. How many times each element is. 2 is 2 times, 3 is 2 times, 4 is 1 time, 5 is 1 time, which is absolutely fine. Now what I have to do next? Now I need to run a loop again on this, right? Because I need to find the first non-repeating element. So I will check first 2. What is the frequency of 2? Okay, frequency of 2 is 2. So this cannot be the first non-repeating element. Then again I will check 3. Okay, 3 is there. Yes, and what is the frequency? 2. So this is also not non-repeating. Then okay, 4. Yeah, 4 is 1. So this becomes my first non-repeating element, right? So what I will do, I will say instead of returning this, right? So what I will do, I will say, I will come out of this, right? I got the dictionary and I will run loop one more time. I will say for num in nums again, right? I'm running the loop again. If, right? So I will get what is the count of this num, right? Count of 2. If from frequency, I will get the count of, now we are sure that this number will be there. So get is not required because all the elements are going from this dictionary itself. In my dictionary, all the elements are going from this list itself, right? So I'll say if frequency of num is equal to 1, right? Then return it. Return num. That's it. Right? This is what we have to do. I have to run loop again on this and I'll check if the frequency of the number, right? So frequency, so the what is the frequency of 2? It is 2. So it will go in this? No, nothing will happen. Then second loop, what is the frequency of 3? Frequency of 3 is 2. Then again it will not go in this if condition. Then again 4, right? What is the frequency of 4? 1. Okay, now it will match and it will return me that, right? And that's it. Now let me run this again. So now it is giving me 4, right? First non-repeating element is 4, you can see, right? Let me add 4 again here. And then we will see what will happen. Now first non-repeating element, it should give me, let me add one more 6, right? So first non-repeating should be 5 now, right? So let me run this and you see it is giving me 5, right? Now what is the time complexity here, right? So if you see, we are running loop one time on this array, right? And again I'm running a loop, right? So 2 times I'm running a loop. So my time complexity will be O n, and I'm running a loop one more time. It is not loop inside loop. There are separate loop. If it is loop inside loop, then it will become O n square. But this is one loop. So if let's say there are 10 elements, so there will be 10 operations here plus 10 operations here in the worst case, right? So there will be 20 operations. So it will be O2n or 2on, whatever you call it, right? So on plus on, right? Which is better than n square, right? 2on is better than n square. N square will be 100, right? So it will be double of number of elements, and this is also called as linear, right? It is just doubling, but it is not that it is if there are 10 elements and it becomes 100. No, this is not happening. So this is also a linear time complexity, that number of operations will be linear. If there are 10 elements, then operations will be 20. If there are 100, then 200. It is linear, just double, right? So this is also overall considered as on only, right? Okay, great. I hope it makes sense. Next, let's solve another very famous interview question, which is based on two sum problem. Right? Very common this is. Now what we have to do in this? So let's say I have an array, right? Nums 2, 7, 11, 15, and the target is 9. So what we need to find is, we need to find that the indices of those two elements in this list, right? Let me make it a little big, this list. Let me make it 1 here, and maybe I will take 2 here and 7 here, right? Okay. So in this list, right, I need to find those two indices whose value sum is 9. So for example, 1 and 2 is 3, right? Indices of those two elements whose sum is 9, right? So 1 and 2 is 3. So this is not a solution. 1 and 11 is not a solution. 1 and 15 is not a solution, right? 2 and 7 is a solution, right? So 2 plus 7 is 9. So my answer will be, right? Answer will be index of these two elements, right? So it will be, this is index 1, right? And this is index 4, 0, 1, 2, 3, 4. So answer will be 1 and 4 because the sum of values at index 1 and 4, 2 plus 7 equal to 9. And this will be given that there will be exactly one solution. There will be exactly one pair whose sum will be 9. Right? So this is the question. 1 4 or 4 1, both are fine. Order doesn't matter, whatever you give. Okay. So if you have to do this with brute force again, right? You just imagine one more array is there, right? What you will do? You will pick this and then run loop over it and see 1 plus 2 is 9, no. 1 plus 11 is 9, no. 1 plus 15 is 9, no. 1 plus 7 is 9, no. Again you will check with 2. 2 plus 11 is 9, no. 2 plus 15 9, no. 2 plus 7 9, 9. Then you will return it, right? But again it will be O(n) square, right? So again you should not do that, right? You can try solving it yourself once, but that is not a optimal solution. We want to solve it. So most of the problems, right, that you get, you can easily solve using O(n) square, brute force. And ultimately in your interview you have to think about how I can solve it in O(n), right? So let's see how we can solve it. Now what I will do, let me define the function. So am I calling? Let me comment this first. Okay, so define a function and I will set get to sum, right? So it will take two arguments, right? One, it will take nums, the array, and what is the target, right? Two things required in input. Okay, so this is my get to sum function signature, array and the target. Now how should I go about it, right? So what I need basically, I need to check each element with every other element, right? Now think about it, right? Once I see a element, I should be able to store it somewhere so that when I'm coming here, so I will run a loop on this basically, right? So I will check one. So first element, it is fine. Let's move to the second element. Now when I'm coming on second element, right? I'll not do a double loop that I will pick one and check in full. No, I'm not doing it. I'm just checking the first element. So I will run loop one. Now for the first element, nothing. At least two elements should be there to check. Now when I'm at 2, I will store it somewhere in the dictionary that I have seen one already, right? If it is seen, and then I will check, okay, that what is required, right? That what is required to get 9, right? So what is required to get 9? 7. So 2 is there, I need 7 and I will store 1 somewhere. So let's say I have a dictionary where I have stored that 1 is there at index 0, right? So this is my dictionary. So after first loop, I will store this. Let me do a comment that 1 is there at index 0. I will store it, right? Now in the second one, right, I need total 9 and this is 2. So 9 minus 2 is 7, right? 9 minus 2 is 7. So I need to check if 7 was there already or not in my list, right? I would have stored it in the dictionary. 7 was there? No. 7 was not there. So there is no pair till now which can give me 9. So again I will store location of 2 is 1 in my dictionary at that point. Great. Now again I will move forward 11, right? Now 9 minus 11 is minus 2, right? So I will check is minus 2 there in my dictionary? Minus 2 is not there, right? So I will say okay, store 11 also, that 11 is there at index 0, 1, 2. Great. Now what I will do? I will move to 15, right? 9 minus 15 minus 6, right? 9 minus 15 is minus 6. Is it there in my dictionary? No. So I will store 15. 15 is at position 3, right? Now I will come to 7. 9 minus 7, 2. I will check is 2 is there. Yes, 2 is there at index 1. So I will say this index plus this index will be my answer. Right? This index plus this index will be my answer, and that is how I will be able to solve it. Right? Okay, so let's write it. It is easy, right? If you understand this logic, what we are doing, right, then it will be easy. You can watch this video again. Just go back 2 minutes back if you don't understand this logic. Once you understand the logic, writing it is very easy, right? So I will create this dictionary. Let me call it seen anything that it is already there or not, or anything. It is fine. I am saying seen that this number I have already seen it in my list. I'll say for, again I will run a loop num in nums. Okay, now I will get that what I need. I need that complement. What difference I need, right? Complement equal to target. So what is my target? Minus this num, right? Target minus this num. So for the first iteration it will be 8, right? And I will see that 8 is there or not. Have I seen 8 already? Now this is the first element, so it will not be there obviously, right? So for this iteration it will not be there, but it is fine, right? So I am saying complement equal to target minus num. So I will get this complement, then I will check if this complement, right, is there in my dictionary. Right? Currently for the first iteration it will not be there, but at some point I will get the complement, right, whatever complement I need, so that this number plus that complement will become 9, right? So target minus num is complement. I will check if this complement is there in my dictionary or not. If it is there, then all I need to do is return, right, return that the index of this, right? Now here I don't have an index, right? If you see, I'm just checking num, so it will give me what it will give me 1 to 11. I need an index also, so I can say index comma and I will say enumerate. What enumerate will do, it will give me index as well as the value, right? Maybe I can show you quickly index, right? Let me just comment it for now. I want to show you what it gives me, right? So I will say print index num, right? And I will just call this function get to sum. Okay, so I'll say print get to sum. Okay, and let's run this. Oh, I can just call it because we are printing it inside. That's fine. Okay. So it is giving me 1 to 11, 15, 7. You see 1 to 11, 15, 7, but it is giving me the index as well 0, 1, 2, 3, 4. Okay, I hope you got it. Okay, so let me come back to the question again and let me remove it for now, right? So I'm saying if this is there, I have already seen this difference, right? I need target minus num. So if it is 1, right? If I have seen I have 8 here in this, then we are good. The sum 1 plus 8 will be 9, right? But for the first iteration it will not be there, but it was there. Then I could have said return index, right, and the index of the value which I have seen somewhere, right? And for that I have to say seen and the index of that complement, right? Where what index that complement is present, right? I'll do the iteration and show you, right? Great. Now it is fine. If I find it, it is great. I will return it and that's it. But what if it is not there? Then I have to add that into this dictionary. Then I will say seen, right, that value which is num, right? I will store this num and the value will be the index of that, right? Great. So I'll run it and take you through again. I know it is little confusing, but it will be clear. So I'll just say print get to sum. right? Print get to some nums target. Let's run this. So see, I'm getting 4 and 1. 4 and 1 means 4 is 0, 1, 2, 3, 4, right? 7, and index 1 is 2. So 7 plus 2, 9, right? Let me add one more number in this. So if I add, let's say 10, and if I run it again, right, I'm getting 5, 1, right? I can add an element later as well. Let's say 15, or let's say 20, right? So still it is 5 comma 1. Okay, so this is clearly fine, right? Now what I'll do, I'll just run over the iteration one more time so that it is absolutely clear to you, right? So what I will do here, I will just say print print scene and print num and scene. These two things I am going to print it, right? Then it will be absolutely clear how these things is working. Okay. So if you see, for the first iteration, my number is what? Let me take the array. Where is my array? Okay, this is my array. Okay, fine. Okay. So for the first iteration, this num is 1, right? Num is 1. And what is there in my scene? 1 colon 0, right? Because there was no complement present in my set, right? Initially set was empty. So it didn't go in this, right? And I added this value 1 and the index of it. So the 1 and the index of 1. Now in the second iteration 2, right? Again I am checking that 9 minus 2, 7, right? My target is I should find a 7. Do I have 7 in this dictionary? No, 7 is not there in this dictionary. So again it will not go inside this. Right? Again I will just add this value and I will say there is a 2 available and the position is 1, the index position, right? Now next 11, right? Again 11, 9 minus 11 minus 2. Is minus 2 there in my dictionary? No, it is not there. So it will add that value again. And it will keep going on like that. Right? So till here it will not find anything. Right? So it is keep on adding, keep on adding, keep on adding. Now when it reaches 7, right? So it will check what is the complement. Target minus num. So 9 minus 7, 2. If 2 is there, yeah, 2 is there. Right? So the moment 2 is there, it will just return this value. It will just return value and function call will be over. That's it. The moment you say return, your function is done and it will return that value. Right? And that is how it is returning me 5 colon 1. Right? So I am returning the index of this element which I am checking currently, which is 7, and the index of the complement. Right? So 7 is there. I need the index of 2 and which I am getting from here. The index of 2 is 1. So I am getting 5 and 1. Okay. So these things comes with practice, right? You should solve yourself once. No matter how many videos you see, if you are not able to solve it yourself when you practice, then you will not be able to solve this in interview as well. Okay. So make sure you practice it just in your mind. First think about it. How should I solve it? What is the algorithm I should do, right? And then after that you should start writing the code. Okay, great. Let's move to the next question. And in this question, we will introduce a new data structure, which is set. And I will talk about set. Right? So the next question is, let's say you have a list. Right? Let me comment it. So you have a list. Let's say this is your list. And you want to find all the elements which are duplicate. So what it should return? It should return all the elements. So it will return like 1. So 1 is duplicate, right? 1 is there as well. Then 2 is there, yeah, 2 is also there, right? Duplicate. 3 is duplicate, no. 4 is duplicate, no. 5 is duplicate, no. So we should get 1 or 2. Again, the brute force is you will do a loop inside loop, right? And you will just check if 1 is there again, then you will add it into this list, right? And 2 is there, then you will add it into a list. So you will create an empty list. And you will keep checking wherever duplicate is there, you will keep adding it, but again it will be O(n) square, right? So let's see how we can solve it with a optimized O(n) method. Okay. Now before I start the solution of this problem, I want to talk about set, right? Set is another data structure. So you declare it as, let's say variable name is scene and you say set. right? Now in this you can add elements. So you can say scene dot add you will use, right? For list you have to say append, but for this you have to say scene dot add, right? This is a variable name which I declared as set, and you can add something. Let's say you can add 1, and let's say you are adding 2, and if I just say print scene, right, and if I print it, you will get a set, right? It is in curly braces similar to dictionary, but it is not a key value pair, it is just individual element. Okay, now there are two properties of it. One is it cannot have duplicate. So if I again add, let's say 2, it will not store it. So if I just do this, see again 1, right? In list, if you add, it will just add it, right? It doesn't have any duplicate issue, but in set you cannot have duplicate. Second main advantage is the lookup is just like a dictionary, right? If you are looking a value, this is used for the lookup basically, right? If you want to check if some value is present in not, it's there or not, then it takes O1 time complexity, right? If you do that in dictionary, that will be ON. So for example, if I just say print, sorry, print uh, 1 in scene. So I'm checking if 1 is there in this scene set or not, right? Let me clear it quickly. Clear. Okay. I think we went into Python environment. Okay. So we'll say, yeah, I'll just run this. Okay. So I'm getting 1 comma 2 from where I'm getting this 1. Okay, I'm printing this. Fine. Okay. So I'm checking if 1 is there in scene or not. Yes, it is there. So it is returning me 2. 2 is there in my scene. Yeah, 2 is also there. So it will return 2. 3 is there. Yeah, it is not there. So it will return me false. And this lookup is O1 time complexity, not ON. If I'm looking this in a dictionary, so if I'm checking 3 in nums, if 3 is there in nums or not, right? This is a ON time complexity, right? Because for that I need to run a loop over it. But for set, similar to dictionary, the hash values are stored, so it will just take O1 time complexity, right? So this is how the set are beneficial. If you want to do a lookup, you want to store some values and you want to do a lookup, you can use it, right? You can use dictionary as well, but dictionaries you use when you need key value pair, both you want to store. If you just want to store one value, not key value pair, then sets are better. Okay, great. Now let's go back to the question, right? I want to find all the duplicates. So I'll say define find duplicates, right? And this will be nums, right? So this is all I need. Okay. So I will define a set scene equal to set, right? What I'll do, I'll just tell you, and I will say dupes equal to a list. So whatever duplicates I will find, I will keep in this list. I will keep appending it. Right? We'll optimize it further. But for now, I'm keeping dupes, right? And whatever elements I have seen, I will keep in set. Right? What do I mean by that? So I'll run a loop for num in nums, right? And I will check that this element is there in scene or not, right? If it is there, then it is a duplicate. If it is not there, then we are good, right? So what will say? If num in scene, right? If num, whatever element 1, if it is there in my set already, so I will append it to dupes, right? Because it is a duplicate, it means, right? Dupes dot append that element now. Okay. If it is not there, then what I will say, I will add it to my scene. So I'll say scene dot add, and I will just add that element now, right? So in the first iteration, what will happen? So 1, it will check if 1 is there, no. So what it will do, it will add that in the scene, right? Again, it will go 2, right? It will check if it is there, no, then it will go to 2 and 2, right? I'll show you. So I'll just print it here. So I will say print Seen and dupes, both I will print, and then it will be absolutely clear, right? So let me just call this function. Also I need to return it, right? So I'll return it later, that's fine. So I'll say print, or I'll just call this function, that's it, right? Okay, so I'll just call this, and now if you see in the first iteration, in my set 1 is going, right? In dupes nothing is there, right? Dupes nothing is there. The second iteration, you see, again there are two elements in my this set that I declared, right? And nothing is there. Again 3, right? Now when it goes to fourth iteration, 2, right? Now 2 is there in my set, yes, 2 is there in my set, it means 2 is a duplicate, so it will just add 2 here in my dupes list, right? Next again it will say 4, 4 is there, no, so it will add 4 to my set, right? And all this lookup is O1, right? And then it will see 1 is also there and it will add 1 also. So this is how it is working. So all I need to do here is return I need to return all my duplicates. There is still one problem, so we'll discuss. So I'll just say return duplicates, then I need to print it, right, to see, right? So if you see, it is returning nothing, something is wrong. Okay, sorry, I need to come out of loop. Yeah, so let me run this, and now we are getting 2 and 1, so these two values are duplicate, right? So once this for loop is over, then only I need to return it. Now there is one problem. Let me add one more 1. Now what is the expectation? I should still get 2 and 1. I should not get 2, 1, 1, right? Because 1 is a duplicate. Doesn't matter how many occurrences are there. Even if 3 occurrences are there, in my output I want to see only once. But if I run this, it is 2, 1, 1. Why? Because again it is checking here, right? If it is there, yeah, 1 is there, so it will add in this list, right? So I'm getting 2, 1, 1. How to solve this? So again, instead of, so we know in the sets we cannot have duplicates. So this dupes also we can create it as set instead of a list. If duplicate is there, it won't go inside that. I'll say dupes equal to set, and then I can just instead of append I have to say add, and that should solve the problem. Now I'm getting 1, 2, right? So this is how you have to think about it. As I said, again if you see, we are running loop only once, right? So it is again a O n time complexity. So most of the questions are around this, that it is O n square, it can be easily solved, or with sorting n log n it can easily be solved, but you have to bring it to O n, right? 95% of the questions are like this, right? From O n square or O n log n, you have to bring it to O n, right? So if you can think like this, you can easily solve these kind of problem. Let's move on to the next question, and very interesting question this one. So here's the question, right? The question name is best time to buy and sell stocks, right? Given the prices of a stock on different days, find the maximum profit you can get. You can buy once and also sell once. Okay. So let's say you have the prices of a stock, right, in a list, right? This is day 1 price, day 2 price, day 3 price, and so on, right? You have to find that what is the maximum profit you can get. Now two things is, one is you can only buy once at any price and sell once. Second thing is, you should buy first and then sell first, right? So for example, if you buy here, right, then you can sell any day after this, right? It is not that you will say I will buy at 1 and sell it 7. No, first it should be buy and then it should be sell, right? So let's see what will be the answer in this case, right? So if you see, if you buy at 7, 7 is highest price, so you will never get any profit, right? If you buy at 1 and sell at 5, then you will get profit 4, right? Again, if you see, maximize will be here. If I buy at 1 and sell at 6, it will be profit 5. So answer will be 5. You can try all the combination, but ultimately the profit will be 5, right? Now, if you have an array where prices are always decreasing, for example, 7, 5, 4, 3, then you can never get any profit. The maximum profit you can get is 0. You can buy at 7 and sell at 7 on the same day, because it is always decreasing. You can never get any profit here, right? Okay. Now, if I have to solve with brute force, right, what I will do, I will run a loop on the array and compare with each price. So I will compare 7 with all the other price. So I will say I will buy at 7 and sell it 1. What is the profit? Minus 6, minus 5, sorry, minus 6, right? Again, buy at 7, sell at 5, buy at 7, sell at 3. So I will get all the combination and see what will be the profits possible. Again, I will buy at 1 and see with every index other than this, right, what is the profit that I can get, and I will store all the profits and keep the maximum one. Again, so I can run this on the all the elements and compare all the combination, right, how much profit I can get. But again, it will be O n square, right? The time complexity will be order of O n square, right, which is not again good. So we want to bring it to O n, right? As I said, most of the time we'll be doing this. Brute force will look like O n square, easy, and then there will be some trick to get to O n. Okay, and it comes with practice. Don't think that if you are not able to solve this question at once, you will not be able to crack interview. No, it is like if you solve some 50 or 100 questions in your interview, same patterns will keep on coming, right? So practice a lot. You can practice on namastesql.com as well. I will show you later, but for now, let's solve this question. Okay, so what we will do, right, if you think about it, we need to keep track of our profit, right, and the minimum price, right? So what we will do, we will start from the first element, right? So we will start from here. Okay, let's assume I'm buying here, right? So my buy price is 7. Let me write buy price is 7 on the first day. Okay, when I go to the next day, right, I will check if the price is less or more, right? So initially the minimum price I have is 7, right? I bought at 7, so initially the minimum price is 7, right? First day, doesn't matter. Okay, now when I move to second day, right, this is the minimum price now. So what I will do, okay, so there is no point buying here. If the next price is less than this, then why not buy at this, right? When you buy at less price, you will always, there are more chances of getting a profit, right? So when I'm moving to next index value, I mean next element, I will check if the next value is less than current value, then I update my minimum price. So my minimum price will be 1. Okay, great. Now again I will move. Now this time I will see, okay, price are increasing, right? So I will check what will be my profit, right? At this point, my profit will be 5 minus 1. So maximum I can get 4 profit. Once I reach day 3, right? In day 3, maximum profit I can get is whatever minimum price I could have bought it, and I can sell here. So profit I could have got 4. So I will keep this profit as 4, and in future we will see if there is a chance of getting more profit. Right? If there is a chance, then we will use that combination. Okay, so this is fine. Now again I will move to 3. Now 3 is less, right? 3 is less, which means if it is less, so if I do 3 minus minimum price 1, it will be 2. So we won't sell this, right? The better option was buy at once, sell at 5. And I will not update my minimum price also, right? Because minimum price was 1. If I had an opportunity to buy at 1, why I will buy at 3? So in this case, nothing will happen as such, right? Okay, great. Now let's move on to the next one. Next is 6, right? Now I will check is 6, right, is greater than my minimum price. Yes, it is greater, right? So I will check 5. The maximum profit I can get is 6 minus my minimum price 5. So now my profit will become 5, right? I will check. The previous maximum profit was 4, but now I can achieve 6 minus 1, 5, right? And again, Now it is reducing. It is 6 and then it is 4. So again it is more than my minimum price, and if I check the profit, 4 minus 1 will be 3, so again it will be less. So my maximum profit will be 5 at any point, right? So this is how I will solve it, and let me write the code for this. Okay, so I'll keep it as it is. This, so I will say define get max, and it will take an array. So let me give prices itself. You can say air, anything is fine, right? So let me keep it as it is. Okay, so now I need to keep track of two things. One is what is the maximum profit I have, right? So that I can, in this variable I will always keep the maximum profit possible, right? And in this I will keep the minimum price, at the price at which I should have bought, right? Okay, so I'll define two variables, and I'll say profit equal to 0 and max profit possible, max profit possible is 0, and the minimum price or minimum buy price, whatever, right? Minimum price, let's say the first element, prices of 0, right? So we will start with 7, right? I can keep it as a infinity as well, so I can say float of infinity, some big number, right? So that when I compare, I always have a lesser, because I want to keep the minimum I as a track. So I can keep a big value, and when I compare with the first value it will be less, and I will be able to replace it. But this is also fine, we can take the first element. Okay, now let's start the loop. So we will iterate over this, right? So for price in prices. Okay, now what I will check? I will check if this price, right, is less than my minimum price, right? That's what I have to keep. I need to keep the minimum price at which I can buy the stock. So I will say if minimum price is less than, or if price, whatever this current price, right, is less than minimum price, right, then I will just update my minimum price, right? Because new minimum price will be this now, right? I'll go through the iteration. So I will say then minimum price will be equal to price, right? So I'm every time I'm going left to right from day 1, day 2, day 3, I'm just checking what is the minimum price I could have bought it. That is one thing. Now second thing, at every iteration I also need to check the profit, right? So that after every iteration I store the maximum profit in this variable, right? And in return I will return this max profit, right? So I will calculate my profit. My profit will be at current iteration, whatever is the current price minus whatever minimum price I could have bought at, right? So that's why I'm keeping the minimum price, so that I can always compare the current price with whatever minimum price in past I could have bought the stock at, right? And then what I have to do, I need to again check that if this profit is more, or the earlier profit I stored that is more, right? I will compare and keep the max profit again. So I will say that find the max of the current profit, right, as per the current price if I sell it on the current day as per the loop running, and the maximum profit I already had stored, right, that I will keep in the max profit. So I will update the max profit value to max of profit and max profit, right? I'll just print everything and then it will be clear. So I will say print. So I'll print three things. One is I will keep minimum price, right? And then price, right? And profit. Okay, so these three things I will print and then it will be clear. So I'll just say get max prices. I'll just call this. Okay, now it will be very clear to you. So what I am saying, initially the minimum price is this, right? Let me take this here. It will be more intuitive. Okay, So minimum price initially is 7, the first element, right? This is my first element, 7, doesn't matter. And again, and then I have the price. So in the first iteration, price is also 7, so profit will be 0, right? In first iteration, nothing much. What I can max do, I can buy at this price, sell at this price, and profit will be 0. Now let's move on to the second iteration, right? Now in second iteration, if you see, this is 1, right? Or let me put price first and then minimum price, right? Let me just say this. Just wait a second. So this is my price and this is my minimum price, right? Okay. So let me run this again. Okay. So now my price is 1, right? Now I'm getting a price of 1. Okay. Now I will check if this price is less than my minimum price, right? So my minimum price was 7 earlier, right? Second variable is a minimum price, right? Yes, it is less. So I will update my minimum price value to 1 now, right? My minimum price value will be 1 now, right? Now what will be the profit? Profit will be price minus minimum price, right? So that will be again 0, right? So I will say, okay, maximum what I can do is I can buy at this and sell at this, right? If I buy at 7 and sell at 1, it will be minus 6. So I updated my minimum price, and the max we can do is 1 minus 1, 0. Okay. Now let's move on to the third iteration. 5. Is 5, so if your price is less than minimum price, no. Oh, sorry. Wait. Okay. Yeah. So if my price is less than minimum price, no. My minimum price was 1. So I will not update my minimum price now, right? My minimum price is still 1. But now I can get the maximum profit of 4. So I will update my profit to, earlier it was 0, now it become 4. So at this point, I can get a maximum profit of 4, right? Then again I will move. The next element is 3, right? Now is 3 less than my minimum price? No. 3 is still greater. So I will keep my minimum price 1 only, right? Now what will be the profit with if I sell today? So 3 minus minimum price 2, right? Still I will not update my max profit because earlier I could have got 4. Why I will sell at 3, right? Okay. I hope this is making sense, right? Now next is 6. Is it greater than my is it less than my minimum price? No. So my minimum price stays. But now my profit will be 6 minus 1, 5. Right? Which means now I will update my profit to 5. Earlier it was 4, so it would have done 4 comma 5, so it will get me 5, right? So at every step I'm keeping track of minimum, at what point I could have bought the stock, and I'm keeping track of profit as well, that if I sell today as per the minimum price, how much profit I could have got, right? And in the end I will return this. So basically you just have to say return max profit here. Return max profit, right? And I'll just print this, and we are getting 0. What is wrong here? Let me clear it. Okay, it is giving me 0. Okay, so the problem here is this return has to be outside the for loop. So what is happening is, after the first iteration only we are just returning, right? So when the for loop is running, after in the first iteration we are just saying return, right? So it is giving me 0, right? So I have to check after all iteration what is my max profit, and then I should return it. Okay, now I'm getting 5. Okay, so these kind of mistakes will happen initially, but as you practice, you will be very comfortable with all of these things, where to keep the return and how to bring solution from O(n) square to O(n). Great. Let's move on to the next question. So next question, we will solve on parsing logs, right? These are very common questions in data engineering specifically, right? So let's say you have some logs of users, right? This is how your logs are. It is a list and it has some text, right, in some particular format. and you need to get an output on each date how many error each user has got. So for example, on first, right, this is my first data. So if you see user 1 has got error only once. So this is info. Info is fine. We don't have to count. We need to count only error. So user 1 has got error once. So if you see on 1st of um, January 2024, user 1 is 1. And user 2 has got error 2 times. You see on the first. So this is what you have to get. Again on second. If you see on second, there is only user 1 has got error 2 times, right? And user 2 is not there because there is only one info, right? So let's see how we can solve these kind of questions. Okay, so what we will do here is, first we need to read each of this element from the list and split it so that we can get all this in a different variable, this date, error level, username, right? So these things we need. So let me first show you how do we get it by using one element only, right? Let me just comment it out. Okay, so I will take logs 0 for now, logs 0, right? So this is my log for now. I'm just taking one just to explain how this works. Okay, so now I will say parts equal to log dot split, right? And I'll see what it will give me. Print parts. But I'll run a loop later, but for now I just want to show you how to extract all of this. So I'm splitting. When I say split, by default it will split on white space, right? If you have comma, you can give comma here. That is split based on comma. Now once I have this information, all I need to do is that okay, get me the date. So date is nothing but the first element of this list. So I will say date, or let's say log date equal to log date equal to the first element. So parts 0, right? Now if you see, I will get this full date including timestamp. I need just the first 10 characters so that I just get the date, because I need date wise. I don't care the timestamp, right? So further I can say give me all the elements from 0 till 9. So 10 elements it will give me, right? Let me print it quickly. Okay, so you see I'm getting the proper date. Great. The next thing we need is what is the error label, right? So label is it error, is it info, because we are interested only in error, right? So I'll say let's say label equal to so it will be the 0 1 first part, right? So I'll say parts 1, right? And let me just print it. You see I'm getting this info as well. The last thing I need is user, so I will say user equal to parts 2, and let me print user as well. You see, so we have got date, we have got the error level and user. These three things we need, right? And just we need to count it. Okay, so let me convert this to a for loop. So I'll say for, so instead of taking a first value, I'll say log in logs, right? And then I will just remove it and I'll just comment it out. Okay, great. I'll just give a indentation and we should be good. Let me run this so that we see for the all the logs entries. Yeah, so we are getting this, right? Now in data engineering, a lot of time you are using some API, or you have some logs in JSON format in a file, and you have to work on it, right? So this is very common task in data engineering. Okay, so now what we will do, we need to now do this count, right? So for that, let me create a function first, right? We will write a function. So control X, and I'll say define logs summary, right? And input will be logs, right? And then I will start writing my code here, right? Let me put indentation. Yeah. Okay. So now what we will do, we will declare a dictionary where we will keep the result, right? Initially it is empty, right? This is my dictionary basically. So I'm initializing it with the empty dictionary. Okay. Now first thing that we need to do, right? Let me comment this, that now when we have to make an entry in this dictionary, right? Only when there is a error, not in case of info, right? So I will say if label equal to error, then I will do some task, otherwise I'm going to ignore everything, right? If it is error, then I will do something. Okay. Now if it is error, now what we need to do? Now in dictionary, we have to have this date, right? If date is already there, I need to update just these values. But if date is not there in my dictionary, right, I need to first insert a record with that date. So I'll say if log date not in my dictionary, right, then make an entry. So I will say result log underscore date, sorry, result log date, right? So this date will go with the empty dictionary, right? So basically this will go in the first iteration and there will be an empty dictionary at that point, right? So I have only, so after first iteration I will have something like this. So like this it will be, and this will be empty, right? Right. Now when next time, now I will start adding these key value pair in my dictionary later, but basically this is what we will have after the first iteration. Okay. Now this is done. Now next what I need to check? I need to check if whatever user is coming, right? If there is an entry for that already, I will do a +1, right, in that date only. Otherwise, I will make an entry that there is one error, right? So I'll say result, right? So this is a dictionary now, right? And within this, I need to update for the particular user, right? So I will use get. So I will say result log date. I have discussed this before, right? That if it is not there, it will return none and we can default it to 0. And I will get this user is there or not. If this user is not there, I will default it to 1. If it is there, then whatever value we will get, we will do +1. Right? And that will do for me. Okay. So result log date dot get user +1. And let's see what is my return result. Right? And let me just call this print log summary. Yeah, I think we have got the answer. Let me just check this. Yeah, I think it looks fine. So on first, user 2 has 2 and user 1 has 1, and on second, user 1 has 2, right? This is the, I think, expected output. Yeah. Okay. I hope this makes sense, and this is very common thing in data engineering when you are working, apart from interview as well. This is a very common thing. You will be working with dictionary list, you will be parsing it, running a loop. So you should be very comfortable with these kind of problems. Okay, so if you want to practice more problems, right? I was telling you that you can practice more problems, right? So you can go to namastesql.com, right? You can go to coding problems. So we have lot of different category of problems here: analytics, Python coding, ETL. So you can just click on Python coding and you can solve the questions, right? Mostly questions are on Python codings are free, right? So you don't have to buy anything. There are around 25-30 questions, so you can get a good hang of the things, how questions will be asked. And after that, maybe you can practice more on lead code, easy questions, and maximum medium questions, right? Not more than that, right? So if you practice, for example, if you practice 100 problems, right, then that will be enough. That will be enough for you to solve any kind of problem during the interviews. Okay, I hope this video helps. Please do like the video because it takes a lot of effort to create these kind of videos, right? Subscribe to the channel if you have not subscribed to the channel. And if you are looking to learn Python from start, you can just go to courses and you can buy this course, and it is very fantastic course, right? You will have end-to-end understanding of Python, how it is used as a data analyst or data engineer or even data scientist, right? And you will build a very good foundation because we have started from scratch, right? So there is no prerequisite as such, right? You can just come and start learning the Python. Okay, great. Thank you everyone. Have a good day. Make sure you like the video, and if you have not subscribed to the channel, please subscribe.